We're now left with implementing the array search function, which is the core of this exercise. Like I said, we're going to use a dichotomic approach, a binary search algorithm. Instead of just re-implementing the iterative version that is provided in the textbook, we're going to here try to implement a recursive version. That's going to allow us also to review a little bit about recursivity. So let's get started by putting the interface, the prototype actually of this function in our .h file. So int search. The first parameter is the value. The second one is the array of data which we do not want to be able to change. And the last one is the size. And we will return 1 if we found the value in the array data, 0 if we didn't. So there we go. Now we're going to make a cut and paste of this. And we're going to go to the hal.c file where we're going to implement this function. Well, implementation is going to be relatively straightforward because I'm going to try to make a recursive version. So what I really need to do in a recursive version is make sure that I can do my job with all those parameters, that I don't need extra one. In this case here, I will need extra parameter. What's going on? Well, the core of the recursive algorithm, let's take a piece of paper to try to work this out. The core of the recursive algorithm is to say that if I have an array this big, okay, I'm going to start by taking the middle element, which is one of the two, depending on how you round up. So let's try this one. I'm going to take the middle element and compare my value to the value of this middle element. And depending on whether this value here is smaller or greater, if it's equal, I found my value, so I can say yes, it is in this array. If it's less or strict, if this value here is less or strict than data index I, for example, well, assuming the array is sorted in ascending order, if my value is smaller than this, I need to repeat my search in this half of the array. If it's bigger, I need to repeat my search in this half of the array. So there is pretty much an equality test, which is going to tell me if I need to stop. And then there is the need to do the same search, the same job, on either half of the array. So how could I work this out? Well, I could say I'm going to give you a start index, which is 0 the first time, and a stop index for your search, which is going to be size -1, right? So I'm going to put boundary on where I need to search. And this is going to be my first call to the recursive search function. This recursive search function is going to look here. This is going to be the first step. Look if this element is equal to the value that is being looked for. If true, return 1. We found what we are looking for. Second step of this algorithm, depending on whether it is smaller or greater strict, I'm going to have to repeat this search, but on a different portion of the array. For example, here or here. How do I do this? Well, I can just call myself recursively with different start and stop values. For example, my stop value would be this index. I would repeat my search between start and what was my middle element index. And last thing, should be careful and try to detect error condition, okay? There are a couple of things here that are uncertain at this step of the design. For example, well, what happens if I have an odd number of elements in my array? What happens if I have an even number of elements in my array? There's going to be some rounding up, rounding down. So pretty much, I don't know exactly, I'm not going to split my arrays in half every time, okay? So there's going to be some need here to make sure that if I cannot find this element, I detect whether I have one element in my array or many left. Let me try to clarify what I meant. Let's take an example here with an array of just 4 elements. At the beginning, the start index will be 0. The stop index will be 0, 1, 2, 3. So I'm going to call my search function with some parameter, of course, and 2 index that tell me where to search, 0 and 3. When I try to assess which one is the middle element, depending on whether I round down or up, I'm going to end up with this guy or the next one. Okay, this is index 1. This is my middle index. Start, stop, middle. Well, if this value that I'm looking for, let's call it val, is actually lesser than the value at index mid in my array, I'm going to repeat my search, but this time my search is going to work between start, which is still 0, and mid, which is 1. At that point, what's interesting is that I call myself recursively with the sub-array delimited by my two parameters. And well, what happened when I try to figure out the index here of the middle element? Well, also, still assuming that I round down, I'm going to end up with this guy here. Okay? And then what happened when I compare? I figure out this is not the value I'm looking for. I'm going to call myself with the middle element index, and this time this is going to be index 0 and index 0. So when the two indexes are equal, well, I know that I can stop. This is my last chance to try to discover whether this element val is in the array. When the two indexes are equal, I compare the element at this index in the array with val. If it's the same, then yes, return 1. If not, return 0, my job is done. So you see, in this case of recursive function, it is not obvious from the start when I need to stop. Okay, I have to work a little with a fictive array here, try to work in my mind the algorithm and its detail before I can come to the conclusion that yes, this is when one of my stop cases. Okay, what would be another stop case? Well, let's try to take an array of size, let's say 5. Okay, let's run in our head what's happening. I start with index 0, 1, 2, 3, 4. These are the boundaries between which I need to search. Okay, my middle element would be element at index 0, 1, 2. Let's say that my value this time is bigger than this element. I need to reiterate my search in those boundaries. So I call myself recursively with boundaries 2 and 4. What happened? Middle element is index 3. Let's say that once again, my value that I look for is bigger than this element. I call myself recursively on the subarray index 3, 4. And I keep going like that until what? Until once again, one of them is going to be the middle element, and I call myself with, let's say, index 3, 3. At that point, I am capable to pretty much give up. Okay? So these two examples reinforce the idea of how the codes are going to work. What would be interesting is for you right now to try to figure out an example. Okay, take a concrete example, a concrete array of whatever size you choose, where the recursive call would end up having a call where one of the number is bigger, the start index is bigger than the stop index. Can this happen? Is it something that we need to look for actively in our code, detect as an error or something like that, or just a sign that we went through the entire array and we didn't find anything? Try to figure this question out and post on the forum question related to that. Or even better, you can start actually by testing in your program whether that case can ever happen. So work it out on paper, try to figure it out, then try to figure out with a battery of tests if this case can happen. And if you have questions along the way, feel free to use the forums. So we are pretty much done here with the design problems with this function. So I'm going to go back to whole.c. I'm going to save, and the next video is going to actually take care of the implementation itself.